Hello, everyone. We are going to study future population trend. Recall our course map. Today we are dealing with the future evolution of the population, the factor labor, or more general, the population. The author of our textbook, Weil, argues that the more distant future is almost completely mysterious. Let's start. The plan for today is as follows. We will discuss about the motivation to study population trend, and we will study about the forecasting population, so how to forecast population. Then we will investigate the economic consequences of demographic change. And lastly, I will conclude and discuss the outlook. Last week, we studied the standardized fact about the population size L and its growth rate N and output per capita Y. The population has increased a lot recently in the left panel, and there is a negative relationship between income per capita Y and population growth rate N in the right panel. So today we are going to investigate what affect the population growth. The size and growth of population are important determinants of the standard of living. The Malthusian mechanism explains why countries with a high level of population relative to their resources are relatively poor, and capital dilution in Solow model explains why countries with relatively high population growth are relatively poor. The age structure of a population and its change over time are another channel through which population affect the standard of living. This is highly relevant in light of the worldwide demographic transition. So, the economic growth in the future will also depend on the future evolution of population. Therefore, today this class deals with forecasting the future of population, which is to a large extent predictable, at least for the next 50 years or so. In addition, we address the question of how the predicted changes in population may affect the standard of living. The latter depends on age structure of population in both the developed and developing countries. Let's see the forecasting population in details. The figure shows the UN World Population Forecasting. In 2015, it looked like a pyramid. But in 2100 forecast, it will be the population structure will be like the bell shape because of the middle age spread. mid-range spread. And while forecasts of many economic aggregates, for example, the real GDP, are routinely criticized for their lack of accuracy, even for time horizons over a couple of quarters or years. Demographers have an excellent track record. In 1957, at the United Nations (UN), the forecast for the world population in the year 2000 was 6.28 billion, which was just 220 million or 3.6% too much. Yeah, due to their reliability, we need to take their forecasts seriously. Yeah, this figure shows actual world population until 2010 and the UN forecast for world population until 2150. Yeah, if the forecast from 2010 for 2150 is as reliable as that from 1957 for 2000, population growth will experience a slowdown. So the slow becomes slow down, and the actual and projected average growth rate for the period 1950 to 2000, 1950 to 2000, and 2000 and 2050, and 2050 to 2100 are 1.8% and 0.8% and 0.2% respectively. So, growth rate of population. So ultimately, the world population is expected to stabilize around 11 billion around 2200. Nevertheless, given the world population size of around 7 billion in 2010, this means a future increase by more than 50%. The forecasts are based on the age-specific survivorship function phi I and the age-specific fertility rate capital Fi, which we already have discussed last week. And the figure illustrates the combination of this information in order to come up with a forecast for population in the year 2001. A combination of the survivorship and fertility rate. Such an exercise can be carried out for each age group and far into the future. So for country-specific forecast, a migration adjustment is also required. So plus migration for specific country. The key issue for the success of this method are the underlying projection for mortality and fertility. So what matters for more in the future, mortality or fertility? First, let's look at the mortality. Improvement in mortality have gone that far that the fraction of girls living through their childbearing years is already very high. For instance, in the United States, it is 97%, and in India, it is 82%. Therefore, mortality, yes, though important in the past, is unlikely to be important in forecasting future changes in population growth, as it is unlikely to have further impact on the number of newborns these days. And nevertheless, improvement in mortality imply that people live longer. Therefore, the number of people alive will be higher at any point in time, which is quantitatively less important than changes in fertility. So we are left with fertility as the key driver for forecasting population growth. Forecasts of fertility are routinely made relative to replacement fertility. That is the level of fertility that is consistent with a constant population size in the long run. For replacement. The level of fertility that is consistent with a constant population size in the long run. In most developed countries, a TFR of 2.1 is consistent with zero population growth. But on the other hand, in developing countries, due to the higher mortality, this value is higher than developed countries. So our long-term fertility forecast near a TFR of 2.1, implying zero population growth, or will fertility remain above replacement fertility? The underlying assumption for the UN forecast in this figure is that TFR will reach the value for replacement fertility in all countries within the next 50 years. This implies a dramatic decline in fertility in most developing countries and a dramatic rise in fertility in most developed countries. But at least for the developed countries, from the current point of view, that this is a rather unlikely scenario. That is figure 7 illustrates this for Japan. One can observe that the difference between actual fertility and its forecast differs dramatically. So actual TFR, but always forecasting differ. In fact, each forecast so far overestimated TFR by far. This example illustrates that forecasting fertility is very difficult. However, there seems a significant downward trend, which suggests that population in the developed countries will shrink. This conclusion is misleading for two reasons. First, people's preferences and government incentives to raise children are subject to change. And second, the currently low levels of fertility that drive the current forecast may be subject to the tempo effect. This effect comes from the rise in the average age of childbirth, which implies a lower current TFR and therefore also lowers TFR forecast. However, such a rise in the average age of childbirth does not affect the average number of children. In contrast to the developed countries, most developing countries have experienced a rapid growth in population due to a massive reduction in mortality and a modest decline in fertility. Therefore, it is the future evolution of fertility that is expected to be the driver of future population growth in developing countries. Then, will TFR in the developing country decrease? And at what speed? This figure 8 tables information on the size of the population and TFR in several groups in the developing countries. Despite the heterogeneity among groups, there is a general common decline in fertility. Yes, common decline in fertility. When compared 1970 to 1975 to 2000 to 2005, most remarkably is the decline in China and India. Okay. But nevertheless, the assumption by the UN underlying the prediction in this figure, that is that all countries obtain a TFR of around 2.1 by 2050, may be reviewed critically. If we would instead assume that all countries remain with their current TFR until 2050, the implied forecast is 14.9 instead of 9.4 billion people by 2050, and 57.1 instead of 10.4 billion people by 2100. Now, another aspect that plays a role is the fact that fertility tends to decline with the standard of living, as deficit in the starlight fact at the beginning. So the negative relationship between N and Y. So the ongoing increase in standard of living in the developing countries may reduce fertility in the developing world. For all the above considerations, we should not take the forecast deficit in the figure 9 for granted. It may turn out to be too optimistic or pessimistic. Let us next focus on the concept of demographic momentum. Recall that a NRR of 1 suggests zero population growth in theory, as each girl that is born will give birth to $1. However, even if we were to obtain a NRR of 1 from the current available data, population growth may decelerate only over decades for two reasons. The rate at which women are having babies, that is TFR, and second, the number of women who are in their reproductive years. The latter implies the first can change for reasons already discussed, and the latter implies that even for constant TFR, if the number of women who are in their reproductive years rises over time, the number of babies born will increase over time. This is demographic momentum. So the effect is expected to last several generations and will imply positive population growth during this period, even for a NRR over 1 from now on. So even for constant TFR, if the number of women who are in their reproductive year rises time, the number of babies born will rise over time. This is demographic momentum. And the effect is expected to be the strongest in countries where current TFR is highest and is expected to be a key driver of population growth over the next several centuries, despite an eventual decline in TFR. So we can conclude that even in the very long run, that is several centuries or even millennium, fertility is expected to be the single most important driver of population growth. Okay, and now an obvious question is how all these changes in the factor of production labor affect the future evolution of the standard of living. So economic consequence of the demographic change. And next, we use the thorough model with positive population growth from the previous section discussed in the last week and carry out another quantitative analysis. In particular, we examine what the model predict for the long-run standard of living given the demographic change. The growth of world population was 1.9% from 1950 to 2000, and its forecast for 2000 to 2050 is 1.8%. A more detailed forecast for several country groups are tabled in this figure 10. Now, while zero growth is projected for the more developed countries, the less developed countries are expected to experience a dramatic decline in population growth. However, population growth will remain rather high for the poorest countries. Okay. And next, we use the ratio of the long-run standard of living of two countries, so I and J, that solely differ in population growth. So that is, Ni is different from Nj. We have obtained this ratio in the last week. So we can rewritten the ratio between standard of living is equal to so population growth rate, differentiation rate, and capital income share. However, now instead of comparing two countries, we will interpret this equation for a single country, but in two different periods. So the J indexes the period from 1950 to 2000, and I indexes the period 2000 to 2050. In particular, the dramatic slowdown in population growth for the group of less developed countries can be captured by 2.1% and 0.8%. And we assume the 5% depreciation rate and 1/3 the alpha is 1/3. So this is this assumption. And The solo model, given that assumption, the solo model predict that the slowdown in population growth may raise the long-run standard of living in the group of least developed countries by 11%. But for the sake of robustness, let's consider a higher capital share in production. So that is maybe if we assume alpha is 2/3, and thus this ratio becomes or 2. So it's become 1.5. So which implies an increase in the long-run standard of living of 50%. Remark, what could cause such an increase in the capital share alpha? One idea is automation. So that is the replacement of labor by robots. But but why is the solo model predicting an increase in the long-run standard of living in response to the slowdown in population growth? Because this weakens the effect of capital dilution. So smaller n weakens capital dilution. Okay. However, recall that a slowdown in population growth does not mean that the population is shrinking. Instead, the level of population will continue to increase. Clearly, for an examination of the consequences of this increase in the level of population, the Malthusian mechanism plays a role as many resources are exhaustible. This aspect is not captured in the above analysis using solo model. A distinct aspect of demographic change in the world population aging. Between 2000 and 2050, the median age of the world population will increase from 26.5 to 36.2 years. So 36 years. So half of the population will be 36 to 2 years or older. The reason is the demographic transition. Declining mortality implies that people become older, and declining fertility implies that there are fewer young and more old people. Okay, and the changes in the age structure for the more, less, and the least developed countries discussed above can be seen in this figure 11. This increase of the fraction of elderly people is most pronounced in the more developed country. Where there will be more elderly people than children by 2050. Moreover, there is a decrease in the fraction of children, which is the most striking in the group of less and least developed country. However, even by 2050, the fraction of children will still be much larger than the fraction of elderly in less and least developed country. Still, okay. And what are the consequences for standard of living? What is more relevant for our purposes? It uh, what is more relevant for our purposes? It the fraction of working age people which we assume to be productive. Recall the difference in GDP per capita and GDP per worker. So, how can I say? Yeah, GDP per capita is GDP over total population, and GDP per worker is defined to GDP over number of workers. And the two definitions imply that relationship between GDP per capita and GDP per worker is like this. GDP per capita is equal to GDP per worker times the share of workers in total population. So Y cap is equal to Y worker times W. And W denotes the working age fraction. The equation 3 illustrates that two countries may solely differ in their standard of living as measured by GDP per capita because the ratio of the number of workers to the total population, so working age fraction, is different. So an increase in W implies an increase in the standard of living, so GDP per capita. Yeah, this is one reason why we should care about the working age fraction. So therefore the number of workers. And policies that try to increase it. Yeah, this matters also for social security systems. Notice that yeah, the figure 11 above shows that the working age fraction is projected to decrease in more developed countries. But it is projected to increase in the less and least developed country. So, what are the quantitative consequences for the standard of living? We can compute the effect of a change in the working age fraction, what on the growth rate of GDP per capita, so y hat cap, by using equation 4. So the equation 4 is the y cap is equal to y worker times w. So we can take a derivative in terms of time. So dy cap dt equal to dy okay t, and no, y dot cap is equal to y dot worker times w plus y worker times w dot. And we can divide by y cap at the both sides. Y cap. So y cap is equal to y worker times w. So we can cancel out like this and easily rewritten in the terms of change. So we can have the hat y cap equal hat y worker plus hat w, so growth rate. So for simplicity, we assume that the fraction of worker is equal to the working age fraction. Okay. And yeah, take the United States as an example. Yeah, it is projected that the working age fraction will decrease from 0.6 to 0.54 between 2010 and 2030. Yeah, so yeah, we can get, yeah, given that the equation 6, yeah, we can get minus 0.5%. Yeah, what minus 0.5% implies that demographic change will reduce the growth rate of the GDP per capita, the y hat cap, by 0.5% per year on average. Yeah, further examples are tabled in figure 12 below. Yeah, by comparing Japan and Bangladesh, we can see how strikingly different the impact of demographic change can be. Decrease, but decrease, but decrease. So it's the positive value. Yeah, this is some value. Yeah, overall, we can conclude that population aging is likely to decelerate economic growth in the more developed world and accelerate economic growth in the less and the least developing world. In addition, recall that there are many other aspects of demographic change also beyond economic growth. Now, for instance, the demographic change may affect institutions and culture. A final issue is how population will be distributed among countries in the future. Figure 13 offers a projection yeah, okay. The figure 13 offers a projection. It can be seen that Asia has the main share of the past, present, and future. And second, Europe and Africa used to be very similar in the past. Also with regard to the standard of living, but diverged starting in the 17th century. However, by 2050, Africa is going to be 3 times as large as Europe. And the last, the Americas experienced a decline in the insight due to European discovery and recovered due to immigration in the 19th century. Increase. In sum, massive intercontinental redistributions are projected next to the changes in countries' relative populations. Both are expected to bring about dramatic changes in politics, economics, and beyond. Another aspect of this development is that the countries expected to have the most population growth are also the poorest. Put differently, while the population in later poor countries will increase, the population in later rich countries will decline. This will in turn affect the growth rate of average world income as tabled in figure 14 below. Figure 14 assumes that the standard of living grows at 2% per year in every country in the world between 2000 and 2050. So the composition by using this table, the composition effect then implies that the growth rate of average world income will only be 1.55%. Even though in the specific 2%. So the composition effect is due to the fact that the amount of population is increasing in poorer countries while it is decreasing in richer countries. Okay. However, we cannot conclude that more people are going to live in poverty in the future. The share of people living in rich countries will not necessarily decrease in the future as more countries may become relatively rich over time. Yeah, think about China and India. And therefore, whether more or less people are going to live in rich countries in the future depends on whether the effect of higher population growth rate or income growth is stronger in poor countries. Okay, let me conclude. The future of population, which is to a large extent predictable through on population forecasting that relies on the age-specific survivorship functions and fertility rate. The forecast critically hinge on fertility rate. In any case, in the baseline scenario, world population is expected to stabilize around 11 billion around 2200. And also, in any case, an important factor in the massive increase in population is demographic momentum. This refers to the consequences of demographic transition so far that is expected to last several generations. The solo model predicting an increase in the long-run standard of living in response to the slowdown in population growth, capital dilution get weaker. The world population aging is likely to decelerate economic growth in the more developed countries and accelerate economic growth in the less and least developed countries. The latter does not necessarily imply that more people are going to live in poverty in the future. Okay, that's all today. Yeah, this is the future population trend and how it affect in economic growth. Okay, and yeah, I will upload the problem set, the corresponding problem set tonight. And yeah, have a nice weekend and see you next Monday. Bye.